Hey everybody, welcome back to my channel, and today we are going to learn about data types in Python, and I will explain what are data types and what data types are available in Python and how you can use them and what type of information they can store. So let's get directly into it. First of all, what are data types? Data types, you can think of them as labels on a box. You can see what items are stored in the box by looking at the labels. For example, there can be a number box and you can store different type of numbers like complex, integers or decimals. There can be a text box that can store different type of words, sentences, and give a whole email. For example, there can be a basket box which can store multiple things like fruits and toys and etc. And data types in programming are the same as the example I told you. Data types help the computer know what type of items or elements are stored in this variable. You can remember data types through this slogan: data types, the right box for the right kind of stuff. So now let's look at the different data types. First of all, we have the different types of data types of numbers. There are three data types mainly, which are numbers: integers, also known as int; floating point numbers, also known as float or decimal; and complex numbers, which are used for advanced mathematics. So an example of an integer would be a whole number. They can be both negative and positive, but can't can be as a fraction or with decimal. Example would be 4 or negative 67. That is an example of an integer. An example of a float would be 9.0, 9.6, anything with a decimal. It can also be negative, for example minus 89.0, anything like that. And a complex number is a number with a real part and an imaginary part. There are two main ways to create a complex number. First of all is to write the number as it is with the letter j. For example, 6 plus 9j. This will create a complex number, or you can also write the same thing through this way. Complex, you can first give the real part and then the complex part, 9. And when you try to print this variable, it will display the complex number as written before. So you can see here 6 plus 9j as we had written before. You can also access the different part of a complex number through this way. If you want to access the real part of the complex number, you can write the variable name plus real, and this will print the real part of the number. So you can see 6, and it will display as a floating point number also as a decimal. And you can also access the imaginary part through this way, and this will display the imaginary part. So those are all the number data types in Python. And next we can look at the text data type, also known as string. Strings can store any text data, for example sentences, words, a single character, or even a whole email. And there are three main ways to declare, or you can say store strings: through one quotation mark, two quotation mark, or even three quotation marks. And I will tell you the difference between them. So first of all, to write a string, you can write the quotation mark and then write anything in it which you want to be a string. It can be a whole word, for example tree, like I am good, or even a single letter like H or H. And you can also store numbers in it, but one difference between storing numbers in this way and as an integer or floating point number is that these numbers can't be used in calculations as they are. You have to do something known as typecasting or convert them into an integer before you do a calculation of them, which I will teach you later in this video. So you can access strings the same as you can access integers or floating point numbers like this. And you will see here it will print the string. And which I was telling you about before, the difference why you use a single quotation mark or double quotation mark is, for example, if you want to write a word or a sentence which contains a single quotation mark, so if you try to write it, for example I am, you use a contraction, so it will not work because Python doesn't know if this is the end of the string or if this starts, so it gets confused. But if you write the same sentence using double quotation marks, it works just fine. You can see here it works just fine. And the use case of the triple quotation mark is that and you want to store multi-line string. If you try to store a multi-line string in a double or single quotation mark, it will not work. So if you want to store multi-line string, you have to do it in using the three quotation marks. And when you try to print this variable, sorry, so it will display on multiple lines. You can see here. So those are strings, and you can access one part of the string or one letter if you're writing multiple words using this way. For example, if you write tree and you want to access the T, so you have to do something called indexing, which is a little bit hard concept, but you can understand it just fine. So if you want to access the T in this, you have to look at the position, also known as the index of the element. So indexing or the position of when string or when which I will teach you about later in the elective data type. For example, list or tuple start at 0, not 1. So if you want to see the position of T or let's say E, the first E in this word, it will be 0, 1, 2, not 1, 2, 3. So the position will be 2, not 3. So if you want to access the T, it will be 0. And now this will print T to the terminal. And you can also access multiple letters. For example, I just want to access TR and want to cut off EE, so I can use called slicing, which will work in this way. So you write the starting point. For example, I want to start at T and end at R. So you can you write the position of the first letter, which is 0, and then you add a colon and then write the end position, which is R, but you add 1 to it. For example, position of R is 1 because counting starts at 0, and then you add 1 to it, so 2, and this will display TR. And I know this is a little bit hard, but try to understand. And you can also do one thing. For example, if you want to write print TE but skip R, you can also add something called step, which will skip based on the number you add. For example, if you want to print TE, you can make the step as 2, so it will display the elements after 2 jumps. For example, it will first display select T, then skip 1, 2, so it will stop at E, and then 1, 2, and then after that 1. So this will display TE. So you can see here TE, and there is also negative indexing. Negative indexing is a start at the end of the string. For example, -1 will be the position or index of the end element, which is E, and then -2 will be the next E, then -3 will be R, and then -4 will be T. So that is negative indexing. So if you want to start from the end, you can use that. And if you write -1 or negative numbers in the step position, it will access element from the end. So that is string slicing and indexing. And if you don't know the end of the string and you just want the whole of it, you can use something like this. You don't include any value, you leave it blank, but you include 2 colons. If you don't know, if you want from the start, you can leave the first position blank, and if you don't want a step, you can remove this. So that is string indexing and slicing. Next up are the Boolean data type. Boolean data type consists of 2 values only, true and false. And these data types are used in logic and conditions. Conditions like if a fan on and is it hot, so don't do anything. If the fan off and is it hot, and turn the fan on. That is example of a condition which are used in if else statements or match case statements if you have studied. If you haven't studied them, so don't worry about it. And let's see an example of a Boolean data type. So, for example, it will in most Boolean data types will be stored in a value like this: if fan on, you can write true or false, which will indicate if it is on or off, and you can print them like any other data type. You can see here it's displayed like any other value. So that is an example of a Boolean data type. Next up is the none data type, which is used to represent nothing. Yes, you heard that right, nothing. If you want A to store no value at all, but you don't want to leave it blank, so you can use the none data type, because if you leave it blank, an error will occur. So you can print this like any other data type, and it will display none. You can see here, and this is also used in conditions, and mainly used when if you don't know which value it will have, or it doesn't have a value yet, so you can use it and then you can update it when you have a value. Next up is the collective data types, which are lists, tuples, dictionaries, and sets. So first of all, we have the list data type, which can store multiple values in an ordered way, and lists are also mutable, which means they can be changed or edited. So let's first start off with an example. Let's list starts with an square. List elements are stored in a square brackets. Tuples are stored in round brackets, and sets are stored in curly brackets. So if you want to write a list, you have to store the elements in square brackets, and any collective data can, and any all of the data collective data types can store all of the other data types. For example, you can store integers and strings and booleans all at once. You can also store another list itself in a list, for example like this, and you can access them one by one, like we did with string indexing and slicing. So if you want to access the first element of a list, you can do like you did with the strings. You can type a square bracket 0, and this will print 5. You can also print the whole list like this. And which I was telling about ordered, lists are ordered, so the way you write them will be the way they are stored and the way they are printed. Not all collected data types are ordered. For example, sets and dictionaries are not ordered, so the way you write them will not be the way they are printed or stored. So because they are stored, you can access them by their index, and you can add elements to the list or remove elements to the list based on their index. If you want to add an element, you can use the append or the insert function. Append is used to add an element to the end of the list, and insert is used to add an element based on a certain index. For example, if you want to add an element between 1 and 4, you can first write the index, so 1, and then what you want to add. So let's say 3. I don't know why I'm writing 3 again. So that's the append 1 also, so you can see. And when you print the list again, you can see on the both of these element will be added. You can see here the before and the after we have added the elements. So you can add elements to a list like that. You can also remove elements from a list using the pop and the remove functions method. And if you write pop like this, it will remove the last element, which will be the list. And if you want to pop is used if you want to remove an element by the index. You don't know what the element is, but you know that it's stored in this index and I want to remove it. we can use that. So if, for example, if I want to remove true, then I can use 1 0 1 2. So 2, this will remove true. And if I want to remove this list using the remove function, so I will have to type out the elements. So I will have to type out 4 and 5, and then this will remove the list. So if we print the list, you can see the data element will have been removed. So you can see here elements are removed. So you can also change already present element. For example, I want to change this to false. So I can change this first by accessing the element. So 0 1 2, so 2, and then I can write is equals to false, and this will basically change it from true to false. And I can do this with any element and change it to anything, any data type. So if I print the list again, you will see it will have been changed, and you can see here it was true and then it became false. So next up is the tuple data type, and tuples are basically exact same as strings, but there is one key difference, that tuples are immutable. That means they can't be changed, and if you try to change them, it will result in an error. So tuples, uh, as the elements in a tuple are stored inside round brackets, and they can also store any data type like this. And one key thing, that if you are only adding one element, you can't store element like this. You have to add element. But if you're storing multiple data types, you don't have to add the count. And you can access the elements in a tuple, like you can add a list with their index. So if I want to access the 5, I can write 0, because tuples are also ordered, so they are based on the index. So like that. And you can't add or change element of a tuple, because they are immutable. So there aren't any methods like there in lists to add an element or remove an element. And even if you try to change an element, for example, like we did with the list, a 0 is equals to 7, this will result in an error. So you can see here it resulted in an error. Tuple object does not support item assignment. So that is the tuple. Tuples are basically used to store items, info or information which is not meant to be changed. For example, name of somebody or coordinates, which is a famous use case. So tuples are basically used to store data like that, which is not meant to be changed or which will not be changed. Next up are sets, and sets are unordered collections of unique values. Sets can't contain duplicate value. For example, if you try to store 3 and 3, sorry, let me do this by the 3 and 3, this will not work. And when you try to print the set, only 3 will be displayed only one time. So you can see here 3. And sets are unordered. That means the elements don't have any index. So if you try to access uh, element of a set using the string slicing or string slicing or indexing method, so it will not work and result in an error. So you can see here set object is not subscriptable. That means it does not support indexing. So you can't access any one element of a set. If you want to access an element of a set, you have to use loops for loop, and you can't access them using string indexing. Sets are basically used when you don't want to store multiple values. And for example, if you want to remove duplicate from a list, you can convert it into a set like this. If we have a list of multiple duplicate values for t to remove duplicates, we can convert it into a set. So set A, sorry, and you can see here the duplicates were, so that were sets. And next up is dictionaries. Dictionaries are used to store key value pairs. There is a key, for example, name colon Rayan. So that is a key value pair. Let me show you with an example. And the dictionaries are declared the same way as such, with using curly brackets. And one key thing to notice, if you want to declare an empty set or dictionary, if you write this and then print the type of the A, it will display it as a dic or dictionary. So if you want to create an empty set, you have to write it this way. So that is it. And now let's look at an example of a dictionary. So dictionaries are also in key-value pairs like this: name, and example John. That's an example of a key value pair. There is a key and then a value. So it can store multiple values. Sorry, it can store any value. For example, you can store a list in it with multiple values. And there can be multiple key value pairs. And if you want to declare new key value pair, you have to use using the comma. And after writing the key and to separate the key and value, you have to use a colon. And another key value could be 8. And then you can store multiple ages. 4, 46, and 24. That's an example. That is an example of a dictionary. And one thing to notice, that the keys have to be unique. They can't be duplicated. For example, if you had a key called name, and if you try to declare another key called name, so that will result in an error. Values can be duplicated, you can store the same value, but the keys cannot be duplicated. If you want to access the elements of a dictionary, you can access it like this. You have to write the key name. If you want to access the name, the value, you have to write the key name, and let's say the John. And that is the way to access. And if you want to add an element or change the value of an key, so then do it like this. You have to write the key name, and if the key doesn't exist, it will just create a new key value there. If you want to add a new key for job, so you can create another list, and then you write cricketer. You can write footballer, and then you can print it. There you go. And then when you print it, you will see it will display with another value pair. And if you do this with an already declared key, so it will just replace the value of the existing key with the new one. You see here name, now you can see that. So you can also update the value of a dictionary using this method. The update can where you can add new values to it. If you want to remove Yeah, so if you want to remove items from list, there are two ways. You can use the del keyword and you can write a and then the name of the key, for example H, and this will remove the key with along with its values, and you can see here. And another way is a dot pop with the key name. But the difference between this the pop and the del method is that the pop method returns a value, so it will return the value of the H key. So you have to store. If you don't want to, you can't create. You don't have to create a variable, and then will just remove it. You can see here it moves, and so that our dictionaries are good for labeling data. So next up, I will teach you how you can convert data type to another data type. For example, a string or a number to an integer for calculation. For example, you have a string for with a value of 34, and you want to use it in a calculation. For example, you want to add it to another number, so a plus 67, and if you try to do this, it will result in an error because a is not an integer or a float or a number data type. So you can see here that is an error. And so if you want to do this, carry out this calculation properly, you have to convert it to an integer, and you can use this. You can do this using the int method, which is called typecasting, changing the data type of one value to another data type. So this will change a to integer, and now you can add numbers to it. You can see here it works out fine, and you can do this to anything. For example, you want to change a to a floating point number. If you want to change a to a floating number, you can do like this: a because to float. Use the float keyword to change into a float. You can use the complex keyword to change into complex number. You can see here it turns into a complex number, and if you want to change it into a list, you can do that. See here, change into a list, separate these two values, and change it into a set. You can change it to a dictionary. You don't change it like so before. You can use the set keyword. If you want to change it to a dictionary, you can use the dict keyword. If you want to change it in a tuple, you can use the tuple keyword, and many other data types. And if you want to check the data type of a value, you can check it using the print type of a. So you can see here a is a string, and it has displayed here class string. Class is basically given. That means it has an it is used an object or object oriented programming. You don't have to worry about it. Just look a string or str. And I forgot to tell you, if you want to change a value into a string, you can use the str keyword. So that is how you can view the type of value. You can also do it directly to that use. Uh, uh, you don't have to use variables directly. You can see here it will display class int. See here you use a list, it will display class list. See here class list. So that is how you can view the type and change the type for typecasting. And there are two main typecasting: implicit and explicit. Implicit means that Python does it itself. It isn't visible. That means if you use an integer in calculation with another with a float, then Python will automatically convert the integer into a float number. You can example would be sum is equals to 3 plus 5.0, and if we print sum, we'll see it will return and float. So it returned 8.0 because it converted that 3, which is an integer, into a float automatically. So that is implicit typecasting. And explicit typecasting is which I showed you, converting the value like this explicitly, and this will result in the same answer as the 8.0. So yeah, that is every data type in Python, and I also showed you typecasting and how you can view types, and I hope you understood these data types, and if you found any problems you can comment out below and practice these data types, use them in projects, and hopefully you will be much better in coding. So like, if you like the video, like and subscribe, and comment out below which video I should make next. And if you didn't understand anything, I can comment down below. I will explain to you, and I will try to respond to every comment. So yeah, that is the end. Take care. Bye.